morning to all of you. Okay. So please look at your notes. Look at your notes. Topic 5. Topic 5. Well, in these some of you haven't even opened your notes yet. Okay, so we are looking at power function followed by transformation of curve. So for this portion here, this is actually senior high. Okay, senior high. So but we will still do it because for us we all know we are IC now, we are IC. Okay, so this part, when you go to senior high, you will have a very easy time. You can see during the lecture, then you will remember. Okay, no lah, so now we will do it. Okay, there are SLS lessons, you need to do the SLS lesson. Okay, ma? There are the SLS lessons on transformation of graph, the total like 4 parts. Okay? Now, first one, we will go through the graph of power function. Okay, I just need you to take out your iPad and just have your decimals ready. Okay, just have your decimals ready. You may need your iPad and your decimals. Okay, ma? Open your iPad, you may need your decimals. Okay, so there are different types. This one is called power function. Power function meaning that we are talking about the index. Okay, there is a certain power like 2 to the power of 3, x to the power of y, and x to the power of 3. This is what is called the power function. If we have y equals to ax to the power of n, where a is positive, generally here, okay, if n is odd, okay, n cannot be 1. Okay, not 1. Because n is 1 is just a median line. Okay, so we are talking if n is 1 here, then this is like asking to set y equals to x power 1. Just a linear line. Okay, just a linear line. Yeah, so for your part today, when you look at this, try to memorize. Okay, you will take time. Try to memorize. Okay, so negative, because for example, if it's negative 1 to the power, okay, negative 1 to the power of 3. So an example like this, right, you see positive x power n. The example, you try on your textbook, then get y equals to x power 3, y equals to x power 5. So they're talking about this equation here. Hang on, just okay? Yeah. So we are referring to this equation, sketching power 3, power 5, 4 and so forth. Okay, ma? Okay, so here n is even. If n is even, we are referring to functions like this. Example, y equals to x squared, y equals to x power 4, y equals to x power 6, so on and so forth. Where you can see that the powers are generally the given number. Okay? Okay, so when it's power 2, power 4, you can see that it's just a quadratic graph. Okay, just a unit. It's just a quadratic graph. And yeah, so this is for the first one. So what if it's negative? Okay, what if it's negative? This one it looks a bit like the DBS bank. You know the DBS bank? The DBS bank. Okay, so it looks in the sense that you see when you compare this and this, right? This and this. Okay, what do you mean by this? This is okay. When n is negative, right? It's something that asks you y equals to ax power n, and you are saying that n is negative followed by odd. So what are they talking about is that referring to graph like this, y equals to x power negative 1, x power negative 3. My a is just 1. My a is just 1. I think it's just negative 3. X to the power of negative 5. Okay? So, x power negative 1, I can also write this as just 1 over x, 1 over x cubed, 1 over x prime. Okay, so if you look at this, right, 1 over x, you see, it is positive. If x is small, if x is small, 1 over small will be take 1 divided by a small number, I'll be very big or small? Big or small? Big. Big. Divided by a small number. If x is small, y will be big. Okay. But if x is very big, if x is 1000, it means 1 over big number will become small. Okay. So here also the same. Just that is negative, for example, negative. So sometimes if you forget, don't worry. What you can do is just, for example, just try perhaps take x equals to negative 10, negative 1, equals to 0, equals to 1. Just try a sketch. So if you know y equals to 1 over x, y will be negative 1 over 10, negative 0.05. Y will be negative 1, y will be undefined, cannot divide by 0, right? Y here, sorry, negative 1. Okay. Y will be 1, y will be 1 over 10. Okay? So if you look at all these, right, then you just plot out the graph, x, y, negative 10, some values. Negative 1, negative 1, give me some values. Somewhere here, some undefined. So allow you to sketch the graph. In case you forget, you can't remember the graph, you can just plot out 5 points, 2 on the left, 2 on the right, 1 in the center, just to see how the graph is like. Okay, this is in case you forget the graph. Okay, so the next one is x squared. Okay, if n is negative 2, what do they mean? If they refer to maybe something like that, x to the power of negative 2, x to the power of negative 4, x to the power of negative 6. We are talking about a negative even integer. Negative, the power is negative and even. Okay, so again, you can see that because if it's a square, right, it looks something like 1 over x squared, 1 over x power 4, 1 over x power 6. X squared, x power 4, x power 6 will never be negative. So if you see, on the left hand side, the graph, here is negative, right? But here is above. Okay, the y-axis is above. So it's above the x-axis. Okay? So, very quickly, let me just help me to draw this. Yes, the next page. Just draw on decimal clearly. Let me just draw on decimal. You copy on the note. Just try for part A. Just part A. example, okay, like 3, 5, 7. If it's even, it can be power 4, 4, 6. If it's negative and it's odd, it will look something like that. Okay. Negative 5, if it's even, negative 2, negative 4, look like that. So what happens if at the first step, it's not an integer, for example, it's fractional. Yeah, so if you look at this part again, one of the things you find is that if n is less than 1, okay, n is less than 1. If you think about it, let's say your number here, you take y equals to x power n, and this number n is 0, 1. Okay, in a sense, no matter how big this is, right, it's going to be constrained by the power. It's going to be constrained. Example, if I ask you to draw y equals to x power half, right? Because of the power half, you are taking a square root. Having a square root, does it make the number smaller or bigger? Having a square root, does it make the number smaller or bigger? In general, smaller or bigger? Smaller. If x goes to big. So you can see that in the sense this curve is being aimed downwards. Okay, okay, aim. Okay, aim downwards. So it's being pushed down. So this is quite close to that. Okay, so from here, if positive, n is between 0 to 1, then this is how the graph is like. Okay, example, maybe y equals to x power half. Okay, but if it's improper, example 4 over 3, 4 over 3 kind of that. If the power is more than 1, the curve is being pushed up exponentially. Okay, so more proper. Let's say if n is more than 1, then the graph will be going upwards. Okay, it will be going upwards this way. Example, y equals to x to the power 4. Okay, but there's quite a lot. So maybe if I were you, just to share this mindset idea, so what if n is negative? You notice that if n is negative, all of them they are not defined on the left hand side. Their x cannot be negative. Okay, because negative 1 power 2, negative 1 power negative 2 is going to jump up and down. It's a discontinuous graph. So there's no left hand side. If it's negative, will look something like this. Example, y equals to x, the power of negative half. Okay, in the sense that this looks very similar to this. Okay, you notice how negative, right? The right hand side, this part, they all look the same. As long as it's negative, they all look the same. Okay, but if it's not an integer, then there will only be one side. Then integer, then there are two sides. So 1, 2, 3, 4, 5, 6, 7. Need to memorize all 7. If you forgot, let's say you can't, you're not able to memorize, then my suggestion is whenever you are asked to sketch, you just try, maybe you sum x equals to negative 5, x equals to negative 1, x equals to 0, or you can put x equals to negative 0.1, x equals to 0.1, x equals to 5. You just plot out 5 points. This can give you an idea what the graph will look like. It can give you an idea what the graph will look like. So for example, if you plot out these points on any of the curve, so let's say if I ask you, you sketch, one day in the exam, one year mid-year, just tell you something like this, you go and sketch y equals to x power 5. Then you're like, oh shit, that time Jeffrey asked me to study, I forgot. Then how? Very simple, use the farmer's way, farmer, okay? No, who okay. The hardworking way, basically, it's a dangerous way. Okay? Can operated. Okay, so from here, you plot x equals to -1. Probably you get 1 point here. X equals to -0.1, you get a point here. X equals to 0, 1 point here. X equals to 1, 1 point here. X equals to 5, some negative. From here, you roughly can piece that the graph will be something like that. Give us just 5 points only. 5 points only. How long? Yeah, so if all else fails, if memory fails, plot 5 points. Okay, plot 5 points. Okay. So with that, okay, one of the things you realize that for this graph, right? For x, this is x in the interval of -1, and the modulus of x is more than 1. This means that the size of x is more than 1 in general. The distance of x from the origin is more than 1. Okay, mod x, you can also look at it as the distance of x from the origin is more than 1. Okay, so you notice that if you just look at this, right? So if I were you, maybe you can try doing this. You use a highlighter. Okay, so this is x power 2. Okay, the one in red is being focused on it. Yeah, it looks something boring, so try your best to follow me. Okay, the one in blue. Okay, so you notice that for the graph, right, okay, power 2, power 4, power 6, what you must be able to do, okay, it's very important, okay, if you look at the power 2, power 4, power 6, right, between -1 to 1, who has the higher y value? X squared, okay, remember x squared. Okay, between -1 to 1, the lower the power, the higher the y value. Okay, so you can see between -1 to 1, between -1 to 1, the larger the value of n, the smaller the value. Okay, or I can say the smaller the value of n, the larger the value, vice versa. Okay, so you can see here, if the power is between -1 to 1, if the power is very big, the y value is very small. Okay, now, stay here, focus. Yeah, open up big. Okay, so from here, okay, so example, because let's say if you consider y equals to x power 2, x power 4, x power 6, right? So you see, okay, imagine x is 0.5. Now consider 0.5 power 2. Consider 0.5 power 4. Consider 0.5 power 6. Now see, who is the smallest value? Power 6, right? Because I power myself so many times, 0.5 is less than 1. So this is the smallest. Okay? This is smaller now. They are very important. But once you cross the boundary, right? Once you cross the boundary, anything more than 1, anything more than -1, example 10. Common sense, right? 10 power 2 and 10 power 4, who's bigger? 10 power 4. 10 power 4 and 10 power 6, who's bigger? 10 power 6. Okay, ma'am? Yeah, so once you cross the 1, you can see that the blue curve, which is x power 6, it will shoot up to be the key, and it never looks back. The higher the power, once x is more than 1, the higher the power, the higher the y value also. Okay, ma'am? So you all need to copy this part. You all need to just copy this part. Yeah. here, okay, I hope you copy all this. If n is odd and n is not equals to 1, then we can see that at x equals to 0, your dy dx is equals to 0. So what do they mean for this? Okay, you imagine, say for example, if y is equals to x power 3, or children? Yeah, so if you cannot imagine this, right, just think of substituting an odd number. Now, what is dy dx? I want to ask Tasha can help me. What is dy dx? X squared. Okay, so if I equate this to 0, right, Tasha, what will I get? What will x be? 3x squared equals to 0? 0. Okay, this tells you that x equals to 0. This is a stationary point, right? It's a stationary point, right? Cannot. But if you do, so children, if you do the first derivative test, the second derivative test is going to get you nothing. Because you can see that if I do the second derivative test, 6x, if you sub x equals to 0, it's going to the 0. So, inconclusive. Alright? So, when we have the first, so we have to use the first derivative test, and you can see that it gives you the tangent in this shape. Positive, 0, positive. Positive, 0, positive. So, 0, 0 is what we call a stationary point of inflection. Alright? It's an inflection point. Right? But if it's even, then very easy, you can see that. And then it's very obvious because, should you remember? If it's odd, 0, 0 is here. Can you see? This is not a minimum or maximum point. This is a point of inflection. But if we're talking about positive even, 0, 0 is a minimum point. Here is a minimum point. Okay? So just a note for your consideration. Okay, this is one of the things to do. Okay, now with that, can you just help me try? Same thing, question 1.1. So help me to label the intercepts as well as the stationary points. Okay, you need to label the intercepts as well as the stationary points. So 30 points, if you get any, help me to label them now. Okay? So I'm on question 1.1. Question 1.1. You are old enough, so when you take out your devices, I trust that you are using it to check the solution, or if you are messaging, I trust that you are messaging people in this class because you are, maybe it's your study group or what. But also remember, you must be professional. Okay? Okay, so okay, children, okay, some of you are asking about this function, x power 5 and negative x power 5. Okay, what do you notice? Can you help me? What do you notice about these two graphs? How are they related? They are a reflection about the y. Okay, why is it good for you to know? It's because it's going to help you with the next part. Okay, same for this, right? This is a reflection. You realize that y2 is a reflection of y1 about the x-axis. It's a reflection of y1 about the x-axis. Okay. You all still need this? You all still need this? Erase. Okay, so in general, if you have y equals to f of x, right? Okay, you notice from here to here, what I'm doing is I'm replacing the x with negative x. Okay, when I replace x with negative x, right? This is actually a reflection about the y-axis. Okay? Here, this is called reflection. We use the word reflection. Okay, right? Reflection. So from here, I'm replacing with f of negative x. What you're literally seeing is this. Okay, you see this is the function, right? This is the function, right? So when I replace x with negative x, you take your hand, go to this x. Okay, so this is negative x. That's right. Okay, so okay so far? Okay, so imagine I draw some graph. Y equals to Sin x, okay. So you see the graph looks like that one. Very sexy, okay, like that. Okay, okay. So what happened is this is why. Okay, now I ask you, y equals to, you replace x with negative x. You replace x with negative x, what will happen? This one will become negative x. Okay, so this will become negative x. Okay, so this will give you, you will reflect. You really reflect. This one will reflect this way. Okay, so reflect this way. Okay, now, I'm not using notes. I not the. Now, this will reflect this way. This, when x replaces with negative x, this will reflect this way. So it's legit. You will learn it soon. Probably next week. Okay. If it's replace x, right, it's about y-axis. Because all the x values are here, right? All your x values are here. When it becomes negative x, they will go over this part. Yeah. All the positive x values are here. If x equals to 1, 2, 3, 4, 5, right? You replace, it becomes negative 1 and so it all replaces around the 1. Okay, no? And continue on Wednesday. Okay. Do a topic 4